I want to spend a few minutes discussing the rules for logarithms. Every rule for exponentiation has a corresponding rule for logarithm, because logarithm and exponentiation are reverse procedures. So we know that exponentiation turns multiplication into addition. For logarithms, it's the reverse. Log base b of xy equals log base b of x plus log base b of y. Logarithms turn multiplication into addition. Logarithms turn division into subtraction. Oops. The log of 1, we can figure this out ourselves. What power do you have to raise b to get 1, no matter what b is? We have to raise it to the power 0. So that's a rule for ourselves. We also have the following. Log base b of the number b. What power do you have to raise b to get b? Well, 1, of course. This next one you have to think about. You don't need me to tell you. You can work it out yourself. It's just a matter of unpacking it in your head. It's an exercise in logic. Log base b of b to the x. Ask yourself this question. What power do you have to raise b to get b raised to the power x? What power do you have to raise b to get b raised to the power x? If you want, pause the video and think about it, because you could do this. If you want to raise b to a power to get b to the x, you raise b to the power x to get b to the x. So this is just x. Similarly, if I take b raised to the power log base b of x, I'm raising b to the power you have to raise it to get x. So if I raise b to the power I have to raise it to get x, I get x. You have to just unwrap those words. If you want, pause the video again and think that over. But these two together tell us that exponentiation and logarithm are reverse procedures of one another. They put into algebra what we already know in our minds. I want to show you another rule. It's called the change of basis rule. Log base b of x is log base a of x divided by log base a of b for any a. This has a major advantage when it comes to your calculator. Most of us have two buttons on our calculator that deal with logarithm. We have a button that's marked log. And when you have log with no base beside it, this means log to the base 10. We also have another button that's marked ln. ln stands for natural log. When you write ln, this means log to the base e. We talked about e in our discussions of exponentiation. So e, remember, is a number between 2 and 3. It's approximately 2.71828 and so on. It's an irrational number, a lot like pi. But let's say I asked you to figure out what log base 5 of 7 was. Well, in our heads, we can work out that this is between 1 and 2 because 7 is between 5 to the power 1, which is 5, and it's smaller than 25, which is 5 squared. So log base 5 of 7 is somewhere between 1 and 2. But let's say we wanted a more accurate answer. We're going to need our calculator. Some of us have a button on our calculator where you can put the base in and then you can put the value that you're taking the logarithm of. But many of us have only these two buttons. So using the change of basis rule, I can choose my a to be either 10 or e. I will get the same answer in either case. So I could just write that this equals log base 10, so log with nothing below it is log base 10 of 7 divided by log base 10 of 5, and this I can type into my calculator. I could have just as easily used log base e. I could have written natural log of 7 divided by natural log of 5. Natural log of 7 is different from log base 10 of 7, and natural log of 5 is different than log base 10 of 5, but when I do this division, I get the same answer. So the change of basis rule will allow me to take the log of anything base anything else for any base I want.